Hi there, in today's session we're going to look at paired samples t-tests within the SPSS framework. So what are you going to be able to do by the end of this session? Firstly, you'll be able to run a paired samples t-test in SPSS following the procedure that we follow today. And secondly, you'll be able to interpret the results in line with pre-stated hypotheses. So when we set hypothesis for our tests, we want to be able to interpret the analysis and make sure that what we have is what we think is really going on. So what does a paired samples t-test really do? Well, you remember that independent samples t-test takes two groups and compares a continuous variable across it. Paired samples t-test differs slightly from this. Paired samples t-test takes two continuous observations but from one group. So essentially it asks the same person for two observations, probably and normally at two different times, T1 and T2. This makes it really useful for experiments. There also are some survey implementations of and survey methods of implementation of paired samples t-test, Martilla and James's importance performance framework being one of them. But today we're going to sort of stay within the sort of experimental realm where we test different time periods to see whether there's a change in people's behaviour. What we do, however, just like independent samples t-test, is assess whether any difference that we observe between our two observations is owing to chance or whether it's genuine. And this is how we state our hypotheses. So what does a paired samples t-test look like? Basically, we can have two different observations, and what we're looking to see is whether these two observations differ in their mean score. You can see here for a satisfaction variable on a scale of 1 to 10, at time 1 the mean score of people was 2.5. At time 2 this changed to 7.5. So what we're testing here is whether between time 1 and time 2 any difference that we observe there, mean difference, whether that mean difference is actually significant or not, or whether it's due to chance. There is something you do have to remember, is that unlike independent samples t-test, we do not need the variance between the two groups to be equal, and this is why the shapes of the curves are slightly different. So equality of variance is not a concern in paired samples t-test. It's as simple as comparing whether those two means are truly different. So what do we need? We need one continuous variable, i.e. interval ratio, on two separate occasions. Okay, so T1 and T2. Our assumptions are fairly straightforward as well. Firstly, we need to make sure that we have a random sample and that we have an adequate sample size. A random sample is important, and we think that an adequate sample size is normally about 50, although some people say 30. We also need normal distribution for both of our continuous variables. Okay, so the question that we're asking ourselves comes from a totally different statistics database compared to what we normally use. This is actually quite an interesting database. I ran a stats course in 2011, and I wanted to test whether people's perceptions of different tests going into, and familiarity of different tests going into the course was different when they came out. Essentially we asked about how familiar are you with different tests at time 1. So on a scale of 1 to 5, 1 being not familiar at all to being 5 very familiar, how familiar would you rate yourself in understanding of t-tests? Some people had a prerequisite knowledge of t-tests, and what we wanted to see was across the board whether we actually managed to increase people's understanding of this test. Therefore, were we as teachers doing our jobs? Did we confuse it? Did it actually go down? Or did it go up? And so we asked a second variable after the stats course had finished at time 2, same thing. What was their level of familiarity after doing the course? We hypothesised that actually the stats course made no difference to their familiarity of t-tests, and therefore we stated as a null hypothesis that there is no change in t-test familiarity after taking a stats course. H1 being that there is the alternative hypothesis that there is going to be a change. So we put those two hypotheses to the test. Now, if you can see our database here, we have two variables that we're interested in. In fact, the questionnaire, the dataset is broken into two sections. This section down to here essentially asks questions pre-course, and these courses underneath, these variables underneath, are post-course assessments of exactly the same variables, so we're able to compare the before and after scores. For the question that's been posed in this particular example, we're interested in question 4H, how familiar are you with t-test at time 1? And question 14HP, how familiar are you with t-test at time 2? You'll know how to test for normality. You'll have seen that in previous sessions. It's a good idea at this stage to run a test for normality for both of those variables. Because we've done this before and we know that everything's fine, we're not going to do that here. We're going to get straight into the paired samples t-test. We do that by clicking on Analyze, Compare Means, and go down to Paired Samples t-test. We click on that. And we're faced with this particular box. Now we can run multiple paired samples t-test at the same time, so different groups. But we're really going to just do one at this particular time, which is looking at the variables we talked about a second ago. We have to move our two variables into variable 1 and variable 2 box. Now I always think it's sensible to move our time 1 variable into variable 1 and our time 2 variable into variable 2. So let's do that. How familiar are you with t-test question 4H? Put that into variable 1. And 14HP, how familiar with t-test time 2? We'll move that across. Now, we don't really actually have to do anything in terms of options. We just have to make sure that we're excluding cases analysis by analysis. Essentially, we're making sure that we've got two perfect pairs of data. So anybody who's included in this test will have had to answer both questions at both times. We'll click OK, and SPSS spits out the following. Okay. In the first instance, let's look at the first table. What this tells us instantly is that we've got 84 perfect pairs. That means that 84 people in our sample have answered both questions. So we probably would have more, and we probably should have more, but in practice, getting two observations from people is often quite difficult. We're also interested in the mean score here. So at time 1, on a scale of 1 to 5, most people say a mean of 1.35, saying that they weren't familiar at all. So people didn't have a very high knowledge. At time 2, this went up to 3.29, so it's a little bit closer to being very familiar. The nature of statistics, the nature of analysis and quantitative methods in general is that one stats course isn't going to be quite enough for you to have a comprehensive understanding of the methods that we apply. However, at least we can see that there is some change. But whether or not this change is actually significant or not, we don't know at this stage. We can look at the correlation and we can see actually there's not great correlation between those two groups. But what we're really interested in is whether the difference, deviation between the two groups is a significant one, and that's what the paired samples t-test tells us. Here we subtract time 2 from time 1, which gives us negative 1.92. Essentially this is 1.35 less 3.28. The really interesting statistic here is our t-test, which is negative 12.59, with 83 degrees of freedom, 84 minus 1, and that with a two-tailed significance test, because we didn't really know whether we were expecting the change to be negative or positive between after taking a stats course, we can see that our value is actually less than 0.05. Okay, so it's less than 0.05, which means that, in fact, I will go even further and say that it's less than 0.01, that we're 99% sure that what we're observing is not due to chance, and that there is a genuine difference between our two observations. That suggests that, yep, something has really happened in their learning of the test, and the intervention has in learning of the course, and that the intervention has worked. We can therefore reject the null hypothesis and accept the alternative hypothesis that there is a change in people's knowledge of t-tests after taking a stats course.